two very stark, different fields that aren't always or typically seen together is kinetics, a field of chemistry that deals with time, how fast things can occur, versus thermodynamics, a field of chemistry that deals simply with the flow of energy when going from either one direction in reaction or the other. However, when it comes to enzymatic properties, enzymatic reactions, both come together in different ways. The typical enzyme reaction, without taking into account inhibitors or anything like that, is simply a substrate meeting an enzyme, undergoing a intermediate enzyme-substrate complex, possibly going backwards to separate, or if the energy is there, for the enzyme to convert the substrate to products. And in biochemistry, typically that product is used elsewhere, so it does not typically meet the enzyme again to go back to the enzyme-substrate complex. Two properties, two constants at play, the dissociation constant Kd and the Michaelis constant Km. Kd is simply looking at it, the rate to go backwards to separate substrate and enzyme divided by the rate to move forwards to form enzyme-substrate complexes. However, with the Michaelis constant, there's an additional rate term in the numerator, which is going from the substrate complex to forming product and enzyme separating. The interesting value here is that Kd is a thermodynamic constant for the affinity of a substrate to bind to an enzyme, whereas Km, the Michaelis constant, gives kinetic information indicative of how much substrate concentration is needed to reach a certain reaction speed to get the enzyme to form products. And overall, taking all this into account, Kd, the dissociation constant, being a thermodynamic constant, can be plugged into our thermodynamic equations for free energy, delta G, which can be correlated to change in enthalpy and change in entropy, delta H and delta S, which will vary with temperature, or to take the Km Michaelis constant, that is related to the substrate concentration needed to reach the velocity at which the enzyme is going at half the maximum possible reaction speed. And therefore, our actual reaction speed can be correlated to Vmax and our Michaelis constant and substrate concentration, therefore correlating in some way, shape, or form thermodynamics and kinetics.